and we're in Chapter 7 on work and kinetic energy, and this is the lecture for Section 4 on power. We have found that energy is what is required to do work, and work is what you can do with energy, and so the energy and work are in the same units of joules. If you were to take joules as a unit and measure it in how many joules I'm using per second, okay, then that is going to be power. So just so you're not confused here, this W is not watts. This W is work, and work is in joules. T is time, that's in seconds, so this is joules over seconds. And joules over seconds is power, and power is named after James Watt. Okay, so scientist. So we've got watts equals joules over seconds. And then a horsepower is, again, United States. No one uses this. A horsepower is how much power one horse can exert. So if you had a good, strong horse, how much work could that horse do per second? Right, so a good workhorse or a racehorse or something like that, no one uses it anymore except I guess my lawnmower, but Americans, we love to be different. So 1 horsepower equals 746 watts. So 746 newtons per second is how much strength one average horse will give you. So just to give you some examples, okay, the human brain uses 20 newtons per, or 20 joules per second of power. That's pretty cool. A person walking up the steps, 150 watts. Okay, so you would have to take his force, so that's his weight, in newtons, times the distance of how high in meters he went up the steps, divided by seconds it take him to walk up the stairs. Okay. Now some plug-in things. A television, 200 watts. A refrigerator, 600 watts. Okay. 1 square meter of sunlight, 1380 watts. Okay, so you could use sun to power electric stations if you had a solar panel. Pretty cool. Car moving at 40. Okay. 70,000 watts. And the Hoover Dam, which is tunnels underneath a lake, and the water squirting out the bottom and making turbines go, is my goodness, 1.3 times 10 to the ninth. So a billion watts. Okay, that's a billion watts. That's not bad. All right, so just a tiny bit of math, and I think that this is a simple section. So you already know that work is force times distance. Okay, work can be any number of things. Work can be kinetic energy, 1/2 mv squared. It can be potential energy, mgh. Generically, though, work is a force times a distance. If you are doing a power, though, it's work per second. All right, so if you were to connive this as distance per second, well, that is distance per second. That's speed. Okay, so your speed times your force is your power. That's pretty cool. Okay, so you'd have to really think about the math is simple, but to jump there and say, oh, it's a force times a velocity, I wouldn't have thought that. I would have just let that pass. But the math is totally no problem. So force times velocity is also that. So the power exerted by the driving force, okay, can be written this way. Okay, we'll do some, I think, easy problems today. No big deal. I think you can get it.